Ever wondered how object-oriented programming works? Well, let's delve into it. Object-oriented programming, or OOP for short, is a programming paradigm based on the concept of objects. These objects can contain data in the form of fields, often known as attributes, and code in the form of procedures, typically referred to as methods. Why is OOP so important, you ask? In today's world, it's crucial in streamlining software development and making the code more flexible, reusable, and easier to maintain. It's a fundamental concept that has revolutionized the way we develop software. Taking a quick step back in time, OOP was developed to overcome the limitations of earlier programming approaches and to better manage the increasing complexity of software systems. So, why are we talking about it? Because understanding OOP can make you a more effective and efficient programmer. Hold on to your hats because we're diving into the world of OOP. To understand OOP, you need to grasp its 4 pillars. First, we have encapsulation. Consider it like a capsule. What goes on inside the capsule? Only what we allow. Encapsulation is all about bundling related data and operations in a single unit, a class. It's like a blueprint for creating objects. It hides the inner workings from outside interference. This gives us control, and control, as we know, is power. Next up, we have inheritance. Just like in biology, in OOP, one class can inherit traits from another class. This is a powerful tool for code reusability. Imagine you're creating a class for a vehicle, with attributes like color and speed. Now you want to create a class for a car. Instead of defining everything again, you can simply inherit from the vehicle class. It's like standing on the shoulders of giants, or in this case, classes. Then we have polymorphism. A fancy word, isn't it? It comes from the Greek words poly, meaning many, and morph, meaning forms. In OOP, polymorphism allows objects to take on many forms depending on the context. Think about a shape. It could be a circle, a square, a rectangle, but at the end of the day, they're all shapes. Polymorphism allows us to treat all these different shapes as the same type of object in certain situations. It's like a chameleon, adapting to its surroundings. Last, but certainly not least, we have abstraction. Abstraction is about simplifying complex systems by breaking them down into smaller, easier-to-handle parts. It's like a car dashboard. You don't need to know the intricate details of how your car works to drive it. You just need to know what the steering wheel, the gas pedal, and the brake do. That's abstraction, showing only what's necessary and hiding the complexity. Once you've got these 4 pillars down, you're well on your way to mastering OOP. So, we've talked about the theory of OOP, but how does it work in practice? Let's delve into the real-world applications of object-oriented programming, or OOP for short. Imagine you're creating a game. You have several characters, each with their unique abilities and appearances. Instead of writing individual codes for each character, you create a character class. This class acts like a blueprint, holding all the common attributes and methods that every character should have. Now, whenever you want to create a new character, you simply create an instance of that class. This process, known as instantiation, saves you time and keeps your code organized. Moreover, OOP allows for code reusability through inheritance. Let's say you have a special character that can fly. Instead of writing a completely new class, you can inherit attributes and methods from the character class and just add the flying ability. As you can see, OOP isn't just a theoretical concept, it's a practical tool that programmers use every day. All right, let's take a breath and recap what we've learned about OOP. We kicked things off by understanding that object-oriented programming, or OOP, is a programming paradigm centered around objects and data rather than actions and logic. It's like building with blocks. Each object is a block that you can customize and manipulate to create a comprehensive system. Next, we journeyed through the 4 pillars of OOP: encapsulation, inheritance, polymorphism, and abstraction. These fundamental principles help us to create robust and reusable code. Remember, encapsulation is like a capsule, keeping data safe. Inheritance allows classes to inherit features from others. Polymorphism lets us process objects differently based on their data type or class. And abstraction means hiding the complex details and showing only the essentials. We then explored the practical applications of OOP, shedding light on how it's used in real-world scenarios. From developing web and desktop applications to creating games, OOP is everywhere. With these basics under your belt, you're ready to dive deeper into the world of object-oriented programming. Who knows? You might be creating the next big app or game before you know it.